In this video, we look at a Python library called diagrams for creating cloud solution design diagrams like this one. Okay. All right. So here we have a simple Python script. You can install the library using a simple pip install diagrams. Okay. And then import the module diagrams. And let's say we want to create a very simple diagram showing only the EC2 instance from AWS. Okay. So this is how we import different nodes. So from diagrams, we have the service provider, AWS, and then the service type, which is compute in this case, right? We can have other services like storage, analytics, ML, etc. Right? So we have imported a EC2 node, and then we call this diagrams module. We give the diagram a name, and then here we define the nodes and the connections. So in this case, it will be a simple EC2 node, and we are giving it a name web, right? So here we have defined two names. This name is used for saving the file in the PNG format, and it is also used as a name for the whole diagram. And then for the nodes also we can give different names. Okay. Now, okay, let me run this script. So this script has created this simple underscore diagram PNG. Okay. So this is how it looks like. Okay. So it's a simple EC2 node. We give the diagram a name called simple diagram, and for the node we give a name of web. Okay. And we have used this optional argument show is equal to false. If we enable it, this diagram gets automatically opened as a pop-up. Okay. All right. So as I mentioned, you can install with simple pip, and it also require the graphviz library from Python. Okay. So here we are importing the diagram, and later we are also going to cluster some nodes. So import the cluster as well. So from AWS, we are importing different nodes related to compute, database, network, storage, integration, etc. Right? So this is EC2, ECS, EKS, Lambda. So these all comes under compute, right? And then we have a database related RDS, Redshift, etc. All right. So we can create the diagram like this, which is what we saw here. Okay. And then, as I mentioned, the default output format is PNG. But if you want to create the diagram in a JPEG format, we can specify using this output format, right? When we run the code in Notebook, if we want to showcase, if we want to display the diagram within the notebook, we can do it like this. Okay, so we can display it. I mean, for example, if I do this, the image gets created. Whereas if you want to show the image within the notebook, display the, then we can do like this. Okay. All right. We can output in multiple formats with single command. So here we are outputting both JPEG and PNG. And we can set some attributes also. For example, here we are setting the font size to 45 and the background color to transparent. Okay. It's exactly the same. As you can see, the font size now is 45. Here we don't see the background, transparent background, but if you open the image, you will see the transparent background. All right. For these solution diagrams, we often need the flow, right? We often connect the directions between the nodes, etc. How the data is flowing, how the services are connected to each other, etc. Right? So for that, we can use these symbols. All right. So here we have three services: this load balancer, EC2, and a database. Now, to the diagram, we are giving it a name web services, and to the load balancer, this LB, and then to the EC2, we are giving the name web, and then the user DB. So we are defining these right arrows using these two greater than symbols. All right. Sometimes we might not want to have a direction. So in such a case, we can use this hyphen symbol, which will be rendered like this. Okay. Now, if we want a left arrow like what we saw here, then we can use this less than symbol twice. Okay. All right. The two important concepts are the grouped workers and the clusters. Okay. We often want a node to be connected to multiple nodes, or maybe the multiple nodes should be connected to other node, right? So in such a case, we will use this concept called grouped workers. Okay. For example, in order to create this diagram, so by the way, we are creating it top down, right? So that's what top to bottom, right? So the direction we set it to top to bottom. The default one is left to right. Okay. Now, first we want to have a load balancer. So here we have a load balancer, and then we want to have 5 workers, right? But they should be grouped as meaning the input connections as well as the output connections should be to all of the 5 workers. So in such a case, we can use a list like type like this. So where we have defined these 5 workers. Okay. And then these 5 workers, all workers should be pointed to the RDS. Okay. So this is what we have here, right? So again, the advantage of defining something as a group is when we connect the left and right or the top and bottom nodes, the connections are made to each entity or node in the workers list. Okay. All right. Now let's look at another concept called clusters, right? Sometimes we want to cluster a group of services like this, right? So here we have clustered 3 services. Okay. And then so what do we do is, so here we have a DNS of 53, so route 53, and then we have an ECS service. So we define these 2 nodes. We haven't connected them yet, right? We have simply defined these 2, and then we want to define a cluster. So here we are defining a database cluster. Okay. And within this database cluster, we have one RDS. So this is our primary RDS. And then if you see, these 2 are again grouped RDSs, right? Because from this one, we are making connection to both of them. Okay. So that's why we define these 2 replicas as a group in the form of this list. So this way, when we connect the primary database to the group, we'll have these 2 connections, or these 2 headless arrows. Okay. And after defining these 3 elements, so we are simply making the connections here. Okay. Let's do just one more, or maybe 2 more. All right. So here we have 2 clusters. So in the first cluster, we have 3 workers, 3 nodes, and in the second cluster, we have 2 nodes. Now, as you can see, within this cluster, we want to define these 3 as a group, so that again, we can make connection to all these 3. Okay. So this is how it looks. So first we have defined these 2 nodes. Again, it's a DNS and load balancer. And then we are defining this cluster called services, which has 3 ECS services, and we define them in this list so that when we make the connection, we have connection to all 3 of them. Okay. All right. So we define one cluster, and the second cluster is this database cluster. Okay. All right. So here we have And then we are defining the third node, which is this elastic memory cache. Okay, and then we are rendering it here. So the DNS is pointing to load balancer, and the load balancer is pointing to this services group where we have all three connections, right? And then from this services three nodes, we want to make connection to this DBS cluster, which has these two nodes, and a separate connection to this memory cache, right? So that's why here we are defining these two. Okay, so the direction, it need not be one way. We can have these branches as well, so that we can design more complicated solutions. I'll stop it here, but I guess you understand. So here also we have clusters within the clusters. So here we have event flows, which is this bigger cluster, and within this cluster we have event workers as a cluster, and then processing as a cluster. So this is how it looks like, right? Event flows, which is this bigger cluster, and within that cluster we have event workers with these three workers, and we also have an event queue, SKS queue, and then we have another cluster processing with these three serverless Lambda functions. Okay. Not only AWS, we can create the GCP solutions as well. I'll post this code in the GitHub, but again, all these examples are coming from the documentation itself. But so you can create these diagrams also with basically the two concepts, the groups and the clusters, and you can import the nodes from the respective cloud providers. Okay, that's all for this video. Thank you very much.